discuss much from what's in this bucket. This is just some things for you in a little while. We'll do a demo where I have time for that. So today, we're going to talk about, primarily, we're going to go into intro to coding. Let me take my hair off. My hair is kind of fuzzy. I've been working, I've been busy, but it's okay. So if you don't mind, I don't mind. So we're going to talk today about Painting 101. We're going to go through our day 4. First, we're going to do a small review while we're going to over the last couple of days. So we already discussed our site prep. We walked through all of the things that you do for wall preparation and getting ready. We discussed some of the benefits of primers and why it's important. Now we get a little bit more into the top coats. So we're going to go through some of the science behind the top coat. Not just theory, but we're going to talk about how some of these products that we use are actually made, the chemicals that's involved in it, and the processes that it takes for them to go from being in a can or being in the natural mineral state to being synthesized and turned into a material that we use for painting. Okay? So today we go into the science of paints. All right? So we're going to talk about what paints are made of. So everybody knows paints are made of a couple of different things. It's pigments, it's solvents, it's binders, and then there's all the additives that make the paints do what they're supposed to do. Very, very simple, but not simple at all. It's a lot of science involved. Some of the things can be complicated to understand. We're going to walk through some of these things. Oh, excuse me. So the first thing we're going to talk about is pigments. So pigments is one of the first parts of paint. So of course, as we know, pigments are used colorants. And when they use colorants from way back in the day, thousands and thousands of years ago, when people painted on their bodies or they painted on, they painted on mountainsides or in caves and things like that, they use pigments. The pigments came from natural things. You can make a fire and use the soot to make a black. You can crush berries to get an indigo or a blue. You can kill certain bugs, or you can do certain things with flowers to pull an extract out to extract the green or the red from different flowers. So pigments are made from natural things. Some pigments are not made from natural things. Some pigments are made through chemical reactions. Some pigments you can create from burning gasoline, and you get an additive, and the additive creates, the product of the burning of gasoline creates a color, and the color is used to create a pigment. That's how you get certain blacks, certain grays. That's how you get certain dark browns. So all of these colors are different. So you have different pigments. So the pigments can be either organic or inorganic. So an organic pigment is something that was made naturally. It's something that was made for instance, the trees have chlorophylls in it. Chlorophyll is green. If you crush up enough trees, or just say you take your white shirt and you rub it in the grass and you get green on your white shirt, that's an example of a natural pigment. An unnatural pigment or an inorganic pigment is something that's created in the laboratory, something that they use chemicals and chemical reactions to create. So certain yellows that's really, really vibrant, that doesn't occur naturally in nature. They create those through chemical reactions. So that's how you get these pigments that you use for your paints. So you have your chemical reactions that make your inorganic compounds. You have your natural earth minerals and salts and different metals and how they react when they're used and combined and rubbed against each other to create friction. That's another chemical reaction, but it's a natural one. And you can use that to create pigments for a natural pigment. So paint manufacturers, they use both natural inorganic and organic pigments to get the best quality. So of course we go through and we talk about how some inorganic minerals, they're made from minerals, but they don't produce very bright and very vibrant colors, but they're extremely durable. And then you have on the other side of that, you have the pigments that are unnatural, that are inorganic, and you can make them as extremely bright and vivid and vibrant as you want to because you're using chemicals and you can make colors. But you have to have both in order to have something that's vibrant, multicolored, and very durable. And so you want to be able to use both. So when paint manufacturers go through their painting, they use both. You go through inorganic and organic pigments to create what we want to be doing. So binders is another part of paint. Binders are the pieces that pull all of the materials together. So without binders, your paint will separate into all of the different chemicals. So if you don't have the right binder together to make your paint work, then you'll have low quality paints use low quality binders. The material separates in the can, or the material separates as you're rolling it. The paint color won't be as consistent and as good. So, paint will not stick to a surface without the binders. The ingredients keep the paint on the surface. So the binder is like the glue for the material. It keeps the paint together, and it also keeps the material locked onto a surface. So if you don't use a binder, I'll give you an example. What's an example of something that have a binder? That's something that has a color and no binder. Water, food coloring. You ever try to paint on food color with food coloring? Yeah, you've done that before?
Yeah.
Yeah, on like construction paper, you use food coloring. Which, you know, the kids, you make the painting with the kids, they use food coloring. But if you try to put food coloring on a piece of metal, what happens? It slide right off. There's no binder. It's a color, it's a pigment, but there's no binder. There's nothing that will glue that surface and make it stick to that material, make it stick to the surface that you're putting it on. So you have to have both. You have to have these two things in order to create a paint. A couple other things you have to have too, but binders mixed with other ingredients, and they cause chemical reactions that produce different qualities and types of coatings. So for instance, you have a binder that's used as a crosslinker. A crosslinker is what you use to make an epoxy or make a lacquer more durable. So without crosslinkers, you have a lacquer that's not as durable. It's not really a true lacquer because there's no binding polymer that attaches to it that increases the chemical hardness. We're going to get into some of the chemistry behind some of this stuff today. So if you want to take notes, please do. Or you can take photos of this and give you an idea. But so two-part catalyzed conversion primers, two-part polyurethanes, two-part epoxies. They all have to use these kinds of binders, lacquers. They have to use these kinds of binders. So there are three kinds. You have acrylic binders, you have alkyd binders, and then you have epoxy binders. So an epoxy binder is one of the most strongest binders in the world. They use all three of these to make paints, but the epoxy binder tends to be stronger, it's more chemical resistant, and it lasts longer. It's also a lot more scratching and marring abrasive. So an epoxy binder, which you would use in floors, is what you would see in certain clear coats. So they have certain border-based epoxies that are reinforced with these epoxy binders, so the material is a lot more chemical resistant and a lot stronger up against marring and scratching. Okay, so these are also known as resins. So they mean the exact same thing, but when you mix a binder with a solvent, they can be referred to as a catalyst. So we talked before about catalyzed lacquers or pre-catalyzed lacquer, or you ever heard somebody say post-cat lacquer. That's when they mix this binder with this material and it creates this different, more durable substance. And that's what you get when you have a two-part epoxy or a two-part lacquer. So that's how you have those. Okay, so those are binders, and then we have the solvents. Now the solvents is what holds all the material together. Without a solvent, all of your materials will disperse in the can. They won't mix together. The solvent melts all of the materials, and as they melt, the chemical reaction works inside the solvent, and they all bind together. So you have a binder, you have a polymer, a binder is a polymer. You have a binder, you have your acrylic pieces, you also have your solvents, and all of these pieces come together and they create the paint. So without the solvent, the paint is just dispersed in a bucket. But when you put them in a binder with this solvent, the solvent melts all of the pieces together, and that's how you get your paint. Say for instance, if you make a cup of, you want to use tea, you want to make some tea, and then you just put your tea bag, you squeeze your honey or your lemon, you put your honey, and you made your tea. You got some lemon drops, you got some honey, and you have your tea bag. Do you have tea? Do you have tea? Yeah. You have tea if you have a tea bag, a lemon, and the honey. You have tea.
Yeah.
That's tea?
Well, that's a mixture.
What you need? What else you need?
Sugar,
Water.
maybe,
So water is an example of a solvent. Water dissolves dirt. Water dissolves cotton. Water dissolves rock. Water dissolves everything it touches. It's a corrosive material. It just takes a lot longer than an acid. But water is a solvent. So this is an example of a solvent. So solvents are substances that hold all the ingredients together. They are the liquid parts of paint. Okay? So that's an important thing. Solvents evaporate as paints are exposed to air. So we talked before about yesterday we were going over the lacquer and we were going over oil paints, and we talked about how the solvents evaporate and what's left is the film that it forms. So that's how it works. It evaporates, and as it evaporates, the solvent or the base that's what's left is that's what your film is. but all the solvents evaporate. The same thing happens with water-based paint. You apply the paint and you smell the paint in the air, right? That's the material evaporating and gassing off of the surface. And what's left is the resin and the binders that create the film, right? So that's important to understand. So again, these solvents can be organic or inorganic. So inorganic solvents produce toxins. That's where you get your VOCs from. That's where you get formaldehyde from. That's where you get your ammonia or your sulfuric acid. These are the things that you smell in paint as it gasses off. That's where you get your phosphorus chloride. Phosphorus chloride is one of the materials that they use in a lot of the lacquers and a lot of the oil-based paints because they off-gas, but they are very durable as solvents. They burn quickly, they evaporate a little slower, but they allow the binders and the polymers in the paint to settle and level out. And that's how you get your most durable film. Okay? So the types of solvents, you can have a polar solvent, and that dissolves particles. So like water. We talked a little bit about how water is your solvent for your tea bag and your honey and your lemon drop. But you need the water to make the solvent to make tea. The same way you need your solvents to make paint. It's important that you have it. So non-polar solvents don't mix with water. So that's how you get your oil paint. That's how you get your lacquer paints. These are, again, they're natural things. So they come from animal fats. They come from oils that are excreted from the earth. You can take these things and synthesize them, and you can create oil-based paints. That's one of the first paints, oil-based paint, one of the first paints made. They didn't start making water-based paints until a lot later. Everything was used oil. That's why a lot of the older paintings last so longer. Well, they last a lot longer. You've seen some of these paintings from 500 or 600 years ago, or some of these paintings that was on walls from so long ago, because they're using oil backing, and that's the reason why they have them and they're able to last a lot longer. Oil paints last a lot longer on canvas too, which is why artists, or canvas artists, canvas painters, is why they use oil paint so much, because it's very durable and it lasts a long time. And the colors can be extremely vibrant. The colors can be a little duller on the oil side, but with acrylics, we'll go into a little bit where the colors are a little bit better. But hydrocarbons, petroleum derivatives. So that's how you get your paint thinner. That's where you get kerosene from. That's how you get, that's how you get your kerosene. That's how you get xylene. So if you ever painted oil paint and you had to use shop primer or use Deckard or something like that for this kind of stuff, oil paint that you would use for deck sealing or for metal, you probably had to use xylene to cut it. Paint thinner is not as hot of a solvent, which means it won't cut as more. It won't make the paint as loose as it needs to be to flow correctly, right? So all of these things matter. So the solvents matter that you use in the paint. You can add extra solvents to a paint to make it do something different, to make it react a little bit differently as you apply it. Some people add water to their water-based paint. I don't like to do that because I think it thins out the color and it thins down the paint a little bit. But there are additives that you can use that are better suited for water-based paints than water. And they will not take away from the color, they won't take away from the durability. But they still give you all of the benefits of having an extra bit of solvent in your material that allows it to flow better. So paint solvents allow the paint to flow. So that's an important thing. Then you have oxygenated, high solvency, oxygenated solvents, which is a high solvency, but it's very low toxic. So alcohol. So if you have a rubbing alcohol, that's a form of a solvent. And this has a high solvency, but it has very low toxic rates. So that's why people are able to use alcohol. You shave your face, you use alcohol to clean up and to disinfect. You know, you have different things, ketones. Then you have esters. So polyester is a solvent when it's in its liquid form. So polyester, they use that in everything. They use polyester in clothes. We use polyester in spray painting. So we have polyvinyl paints that we use that we can spray. Polyester paints that you can spray for finishing certain things like vinyl or for finishing tabletops or different things like that. Polyester paints are also a thing that we use. And they also use polyesters and use oxygenated solvents in medical stuff, in the medical field. They use it in food. They use it in hair care and cosmetics. So these polymers or these solvents are widely used. But for paint, we mostly see non-polar and polar. And we use the hydrocarbon solvents because they're able to dissolve paints and give us better finishes or help us clean up after we finish painting, which is what thinners are designed to do as well.
So polyurethane is from polyester?
Polyurethane, yes, it's from a polyester. So they have the same, the chemicals work like this. So an ester is like we said, the solvent. So it's a liquid. The poly part is what a polymer is. So the polymer mixes with the ester. And so the poly is the solids. It's the polymers, that's where you get your coloring in, all of those things, the binders, those are all wrapped up in that poly. When they put it in this ester solvent, you can use that and they mix together, and that's how you're able to spray things out. And again, when the ester is dry, when the liquid part's dry, all of the solvent stuff is all of the stuff that's left behind, and that's where you get your film. So like this, for instance, it's a shiny piece, and it was sprayed with, this was sprayed with a 2K polyurethane. And this was done a few years ago. It's been kicking around in my garage and in my van. So even this, how durable it is. But you get this shine and you get this durability from those two chemicals mixing together. And then when we spray it on, it sits on the surface. Part of it, because there's a chemical solvent, it melts into the surface like we explained yesterday. But then on top of it, everything gases off, the air. That's why we smell the paint when we're working. The paint is gassing off. That's the paint evaporating. That's the solvents evaporating off of the surface. And what's left is the binders and the polymers and all of the pigments that they put in the material. That's why sometimes you'll walk up to things that have been sprayed and they lay flat, and you wipe your hand across it and there's dust. It's not really dust. That's the alcohol or the solvent is all evaporating, and that's what's left. So that's an important part of it. That's how all of this works. Okay. So the additives, these are the parts that make paint more durable, or make it more shiny, or make paint scuffing and marring resistant. These are the things that make paints mold resistant or mildew resistant. These are the things that give the paints its qualities, that make it more useful for whatever the substrate is or whatever the use is going to be. So certain paints are meant only to be used indoors. Other paints are meant to be used indoor or outdoors. Some paints are designed only to be used on drywall and previously painted surfaces. Other paints can be used on any surface, whether you primed it or whether it's raw wood or not. So understanding how these additives work and what they are will give you an idea on the kind of material that you would use for your top coat. So some of the ingredients that help paints achieve different results and qualities. There's some additives that improve durability and protective qualities. So you have some paints that are rust inhibitors, yes?
So just to backtrack a little, you said some paints are used on drywall. So the paint that is on drywall, would you use it on concrete?
You can in certain situations. So there are certain paints that you only use on drywall, and then there are paints that you really shouldn't use on concrete. And they can be the same, there are paints that you can use on both surfaces, but then there are paints that's designed only for concrete. I'll give you an example, something called block filler or satin fill. So these are designed to seep to absorb into concrete and still let it be breathable, so that the concrete doesn't spoil or break later, so that the concrete becomes ineffective. But it's designed to seep into concrete. Only concrete. It's not really designed for drywall. It won't have the same protective properties. It won't serve the same purpose. And as a matter of fact, on drywall, it's not as effective. It doesn't do exactly what it's supposed to do. So drywall needs to be sealed, where a satin fill will allow concrete to breathe a little bit.
I ask because I'm from the Caribbean, and when I go for vacation, I like to take up jobs. I don't know, I just like to keep busy. So most houses in the Caribbean are concrete, right? They're built cement. So some houses are wood. So last time, earlier in the year, I did a couple wood painting, which I was familiar with. But I just thought, because maybe, I would have probably tell the guy that I'm painting concrete wall. Maybe yes. So maybe that would be helpful. But otherwise, I would not have known. It's two different.
Well, again, you have latex paint and then you have acrylic, right? So we know that latex is great for wood, certain things that have been painted before, not necessarily raw wood, right? We also know that acrylic, you can use an acrylic primer on wood or concrete or drywall. So that just alone is an example of a material that you can use that has multi-purpose, it can be used almost universally, versus a material that is designed for one or two specific uses, right? So as we go through it, certain additives that they put into an acrylic that's designed to go on masonry, and it's also designed to go on drywall, and it can also be used on metal. They'll put more additives into that material, which makes it more expensive also, but it's over-engineered, but what you get in return is you get higher value because you can do more with it, right? Whereas you have some latex paints that are only, again, designed to go on previously painted stuff, so only for repaints, really not really much outside because of the stretching factor on latex. It'll pull off a surface. The heat it's not as heat resistant as acrylics are. So that's why acrylics are designed better for outside because of the additives that they put in it, right? So we'll go back through. I'm gonna talk about the additives, they improve the durability and the protective quality. So we have some additives that you can use in paint have rust inhibitors. So Yemi, we talked about yesterday, you were telling us about iron oxide. I went and did a little research. That's a rust inhibitor. And the reason why you may spray it before you actually apply color is because some paints, they put that additive into the paint. So some paints have that rust inhibitor built into them, and then others don't. So you may be in a situation where you need a rust inhibitor primer, and so you apply that first, and then you put your top coat. But some primers and some top coats already have rust inhibiting primers additives built into them. So that might be a situation where you may need to have a rust inhibitor and you don't have one in the material that you're using for your top coat, so you have to spray it beforehand. So that might be a good example of why that might be happening. But then you have defoamers. So some paints will foam unless they have these special additives in it. So all paints have defoamers to prevent that from happening. You have humidity resistance. So paints that work well in bathrooms, so kitchen and spa paint, that stand up against humid areas, so stand up against a lot of water in the atmosphere, and the water doesn't absorb into the walls or into the paint. Some paints have that as well. You'll find that more in kitchen and bathroom paints. You'll find that that's an extremely important element for exterior paints, right? So then you have some additives that resist cracking and fading. Again, all of these things are not added into every material. So understanding which material has certain additives or which material have certain qualities will make you a better finisher, because you'll be able to provide a solution for any problem that your client or your boss presents you with. So it makes you, the knowledge is what sets you apart. That's what makes you unfireable. Eventually it makes you unhireable. We'll get to that point at some point. But flaking resistance, then you have thickening agents, so paints don't splatter. You ever use some paints that's very thin and very viscous, even if it's meant for walls and you roll it on and it spit back at you, you can't help it. No matter how slow and how patient you are trying to roll it, it's always going to spit on you, because this paint doesn't have these thickening agents. And then we have other paints that when we did with the primer yesterday, we put the brush in it, it's like putty, thick, right? Very, very thick, very viscous, right? So different materials carry different properties. All of these things are what matter. So then you have surfactants. So surfactants are like soaps, but they make paint stable. They hold everything together at one time. So you're able to paint a wall, and the paint on this end and the paint on that end is the same exact color and the same consistency. So you have to use these surfactants to stabilize the color and stabilize all of the pigments and all of the ingredients in a paint. That's an important thing. So that's what makes paint stable. And then you have biocides. Biocides are what you use if you're painting exterior in an area. You want to make sure that you have biocides in your paint, because that's going to kill mildew, that's going to kill mold, and that's going to prevent it from growing on your surface.
Is that why? Okay, so I use primer that says mold and mildew resistance or protecting from mold. Is biocides that they have in
That's
the
one of the
primer?
additives that more than likely that they use to put in that. Now you can find exterior paints that have biocides in them. Now this is a fun fact. You should never use exterior paints indoors unless it specifies that it's indoor-outdoor use. If you read a paint label and it says for exterior use only, that means it has a high concentration of mildewcides and biocides. And what that means is the paints may produce toxic off-gassing or leach toxic off-gassing that might be damaging to your health if you're breathing it in indoors. in low ventilation areas. Even with all of these vents, this is considered a low ventilation area because the air is only escaping 1, 2, 3, 4, 5, 6, 8, 10 places. Where outside, the air is expanding and is moving every cubic inch. The air is coming from every direction. So you're not limited in your airflow. So you can use these biocides and these paints with these mildewcides outside because they won't affect your breathing directly. But with some of these materials, you cannot use them indoors because the chemicals, the additives that they put into the material could be damaging to your health over time. So it's important to understand that.
Okay, if I'm painting a nursery, right, and you have kids, babies, that not moving around, they're just here most of the, then a paint with, well, not paint, but let's say prime, because you have to prime first. Then I should be using a primer that has, let's say, mold and mildew there.
No, it's okay to use it. Again, if it's rated for indoors, you'll be okay. If you're working in a situation with people who have fragile lungs or people who are babies, like little kids like that, then they have paints that are zero VOC. So they have no volatile organic compounds. So we talked before, that's where you get your solvents from. So the solvent base in those paints would be really, really low to account for the fragile nervous systems and the fragile respiratory systems of the people who might be using those things. So they have Benjamin Moore and different products, different paint manufacturers. They have products designed to be used in areas that are low, that need to be low VOC to accommodate for people's sensitivities or to accommodate for people's immune systems and all these different things. So all of those things, again, because different materials will have different additives, which give them different qualities, which makes them available and useful in different spaces. Every paint, there's no such thing as a one thing that does everything. It does not exist. So in order to understand how to best serve your clients, how to best become the best painter you can be, is to understand how these materials work, the additives that they put in them, and how they make the paints react to different things, where the paints can be used. That's what's going to set you apart, is understanding these things, right? So the most common types of paint, we all know latex. We talked more about acrylic and understanding the difference between acrylics and latexes. We're going to walk through it again. You have your oil base. One thing that we have not really spoken about is waterborne alkyds. So those are paints that are oil paints that are wrapped into a water molecule. And the same way, so it has water as a solvent. They figured out a way to combine oil and water-based paints together. So you have a paint that washes up like a water base, but it dries, it lays down, and it performs like an oil. So that was a revolutionary thing about 15, 20 years ago when they started designing that. Then you have urethanes, and then you have your epoxies. So we'll walk through some of these, and some of these we might not get to, I'm not sure, we'll see. Okay, so latex paints. Of course, you know latex paints, they're water-based, they have synthetic polymers. That means that they are inorganic. That means that they're not natural, which means that they're chemically made, which means they're not as smelly as oil. So that's why latex is there. Latex, you can produce very, very vibrant colors. The color and the vibrancy in the color that you get, what you don't get is the chipping and the marring resistance that you would get with the oil base. So understanding these again. So there's advantages and disadvantages to all materials. So advantages to using the latex paints is very fast, it's fast drying, it's easy to clean up, water-based, water and soap clean up, very, very easy to do, it's very user-friendly. So people who are not professionals, they feel a lot more comfortable using the latex paint because if they make a mistake in an hour, they can fix it. And also, if they are using it, they can paint inside their house and not worry about the toxic fumes that off-gas like you would if you were using oil. So it's important to understand that. That's why a lot of homeowners use latex paints. You know, they use mostly on interiors. It's very rare that you find a latex that's made for exterior. You'll usually find more acrylics designed for exterior use. And then again, the low VOC, so the fact that it's not so smelly and it's not so toxic, the off-gassing fumes is very important. The issues that come up from using latex paints revolve around the limited use. So you really can't use it on things that are not primed. So if you didn't apply a primer to the drywall, or you didn't apply a primer to the raw wood, the latex paint won't work as well. So if you don't apply a primer to a drywall and you paint on it with latex paint, what's gonna happen? If I give you a gallon of latex paint and I say, I want you to go paint this room. We did all the drywalling, but we're not gonna prime it. We just want you to paint latex. If you paint this latex 2 coats, what you think is gonna happen next to the plaster? It's gonna absorb it. Is it gonna stick to plaster? No, peel right off, right? That's why you need a binder. That's why you need a primer, right? That's why you need a primer. That's also why you don't use latex on raw plaster. So latex have some limitations, right? So that's just one of the limitations of latex. Again, latex paint, it might be dry to the touch in an hour or 2, but it's not fully cured for 30 days. Most people don't know that. A lot of painters don't even know that. When you paint a surface, you have to wait 4 weeks before it's fully cured. A full cure means it's hard to the touch, and the paint has dried from the top layer on a microscopic level. It's dried from the top layer all the way through to the substrate. That takes about 4 weeks to happen. Most people assume that the paint is dry, oh, I can just do whatever. But if you ever walk up to a paint that's been dry for a day and you try to put your fingernail through it, you can put your fingernail through the film because it's not cured. It might be dry to the touch, but there's something called a curing process. This is a 2K polyurethane. What this does is this stuff cures as it dries. So it's called a self-sealing material. So we did a stretch test here. That's the primer underneath it. The primer won't scratch off. It won't scratch off the primer. It's bonded fully to the surface. And that happens in 24 hours, as opposed to using a latex, which, like I said, takes 30 days. Right? So you can test it and see just so this was sprayed with an HVLP gun. It's a 2K polyurethane. Just to give you an example of the difference in the finish. Okay. So again, they have long curing time latex paints, and they must be stored away from the cold. If you didn't know this, I'm gonna tell you this now. Oil paint, you can leave it outside in a snowstorm. In a frozen snowstorm, you can leave oil paint outside, and in the springtime, you come and pop the can open, or you shake it up and pop the can open, and you can use it. Because oil doesn't freeze like latex. Oil freezes as such, it's like sub-zero, such a Arctic cold level that you need to freeze oils. Whereas latex is water-based. Latex freezes at 32 degrees Fahrenheit or 0 degrees Celsius. So it freezes at normal water freezing points. And once latex paint freezes, it's unusable. The binders coagulate, the solvents stop working, they evaporate in cold weather, they don't work the same way. So if you've ever had paint freeze, you use it in the fall, and then you put it in the garage and it freezes all winter, and then you take it back out in April or May and try to use it, it won't work correctly. Sometimes you'll see little crystals in it, even after it's completely dry. Those are the binders. Those are the pigments in the binders that coagulated. They got together and they just locked into each other, and now you can't really use the paint. It's basically just water for a wall. It's a colored water. You really can't use the material after that. So you have to keep latex paints away from the cold weather. So they're very finicky with weather. It's temperature controlled, it's temperature dependent. The use and the maintenance of it, because you can't use latex paints, you can't use latex paint and paint under a certain degree. You can't use latex paint and paint over a certain degree. There's a window that you have in order to use this material. So it's very temperature dependent. But because it's so user friendly, a lot of people use it in their homes. But then for commercial, it's not the best thing to use. So there you have an acrylic. And acrylic paints we talked about yesterday, they're water-based, they're acrylic polymers and resins. But it's a water-based material, so it dries fast, it has great adhesion, and it has very vibrant colors again because it's a water base. So it's an inorganic compounds that they use to make it. It's very durable, it is weather resistant, it's UV resistant. We talked about it yesterday when we used the demo for the primer, how that acrylic primer flows onto the material, how it dries, how it flattens, how it fills the color locks onto the surface, and it dries super quickly. So we already have an idea. You can use water to clean up acrylic paints. It won't crack or chip. It's extremely flexible. Even in its rigidity and its toughness, it's still quite flexible to use. The disadvantages, really the the main disadvantage with acrylic paints. They over-engineer it. They put so many additives in it, which makes it more expensive than normal paints. So the primer that we used yesterday, this Aqualock, that primer is $70, $80 a gallon. $70, $80 a gallon for a primer. They have been, the primer, the shellac primer, $110, $120 a gallon right now. So these materials are higher value because they do more, they're more universal. You're able to do more with them, which means you might require less of them. Because they put so many different things in them, they make them more expensive, right? So it dries extremely hard. If you ever make a mistake with the acrylic paint, say you had to do an accent wall and you had it next to brick, and you painted your acrylic paint on this accent wall and a little bit got on the brick. Acrylics, because again, they kind of absorb into materials, they're very difficult to get out. So that's one of the downsides of using an acrylic paint is one, if you get it on something you do not want it on, it's very difficult to wash it or remove it. It's basically almost permanent. So you have to grind into a surface, and you'll see you can cut into a surface and see how far down an acrylic paint will bleed into it. It's kind of amazing if you ever want to do like a experiment. So that's your acrylic paints. And then we get to oil-based. So oil-based paints are traditionally the oldest paints in the world. The first paints was made from animal fats and from oils, natural oils. So oil paints give you the best durability, they give you the most longevity, and they also give you the most headaches from the fumes and the VOCs that you use, that you expose yourself to when using them. Oil paints stink for a very long time. It takes anywhere from 8 to 16 hours for oil paints to dry completely. And because of that, a lot of people prefer not to use oil anymore. Even though at one point everybody used oil everywhere. Because you just imagine everywhere you went that there was a paint job going, you have this crazy oil smell right to your face everywhere you go. You need a thinner to clean it. If you use a brush with oil, then you're going to need about a half a gallon of thinner to clean an oil brush. It's almost worth it to just throw the brush away and buy a new one. So you only can use oil with specific tools. Specific brushes and rollers are designed for oil paint. So you have to keep that in mind as you use it to produce the best finish, but it's one of the best finishes in the world. It gives you the smoothest finish. It self-levels. We talked about that yesterday, how some paints will level and bridge over, so you can brush it in, and in an hour there won't be any brush marks because oil self-levels. And it self-levels because the solvents take so long to gas off and dry out that it has time for the paint to just slide along the surface and fill all of the cracks and all of the divots that's made from brush marks and anything. Oil paint will fill any crack. It's almost like you pour water on the surface and it finds the level. So that's how it works. It just takes a lot longer to gas off and dry out. But it's extremely durable. It's great leveling and bridging, little to no brush or roller marks. It's extreme moisture resistant. So a lot of people back in the day, they would put oil on their baseboards and their doors. They put oil paint in their kitchen and their bathrooms because then they weren't worried about condensation. They weren't worried about any kind of water damage. And they weren't worried about mopping the floor and getting water onto the baseboards because they had oil paint on it. It's a lot more durable than latex. So you're not running the risk. Again, that slow drying is one of the disadvantages. The biggest disadvantage really is the high VOC and how toxic it is to use. If you had to wait 16 hours for a water-based paint to dry, but then you won't have to paint again for another 20 or 30 years, would you use that water-based? No? If I could give you a material that won't make you sick, that won't be hard to clean up, and you can use it one time, and you'll never have to paint that surface for another 20 or 30 years, would you use that material? You would?
Yes.
Yes, I would too.
Save money,
save everything, right? Save your health as well.
Yeah.
Well, so they make oil-based material, but then there's another material that they use that's similar to oil and similar to water. We're going to talk about that one as well. But the reason why people stay away from oil-based is because you get all of those qualities of not having to touch it again for another 20 or 30 years, but at the expense of while you're doing it, you're exposing yourself and your nervous system to a lot of toxins. You're going to ruin your brush and lose it. You're going to ruin your roller and lose it. But who cares for 20 years? But then it's the stuff that happens to your body that you have to consider.
So would you say to use oil paint on the outside, cause you don't have to go back for long.
I wouldn't use oil paint outside because
No?
it's organic, right? So it will form mold, and it will form mildew, and you can't. And oil paint it promotes mold and mildew because it's an organic surface. It's an organic compound, right? So mold and stuff is attracted to it. So unless it's on metal and it's on something that's non-ferrous metal, that means it doesn't breathe, then you can use oil on that. But you should not use oil on concrete. You should not use oil on wood outside.
So they don't have nothing that would have oil in it, because I'm looking at the durability and outside, so you don't have to go back and clean it for a long time, but they don't have something with oil mixed to help, or should I say like mold and mildew resistant with.
Not really, not really. It's what they use acrylics for. That's why they created acrylics, because you get the best of those worlds. But then on the interior, they make hybrids. So we're talking now about the hybrids. So hybrids are waterborne alkyd paints. So waterborne alkyd paints is when they take a oil-based paint, and what they do then is they wrap that paint molecule around in a water molecule. So they have oil-based polymers and binders. They have oil-based pigments, but then they use a water-based solvent. And the water-based solvent, when you apply this material, it lays out flat, and then it off-gases this water-based solvent, so it dries a lot faster than the oil, slightly faster than the oil. Not the same amount of time, not as fast as a water-based. But when it off-gases, the oil, the alkyd sediment is what's left. So you get all of the advantages of having an oil-based material, all of the hardness, all of the longevity, the smoothness. You get the lack of chipping and marring, but you get that at the same time. You're not dealing with the high VOCs. You're not dealing with it taking 16 hours to dry. It might take 4 or 8, but not 16. You still have to wait a few weeks for it to cure fully, like a latex, because it's not completely an oil-based material. But once that process is over, what you're left with is an oil-based coating. Essentially, you have an oil-based coating that you use a waterborne delivery system for. So we talked about the solvents and how the solvents are what makes the paint wet. In this case, you have a water-based solvent, and it's used to deliver an oil-based system. So this is like the newest technology, one of the newer technologies in our industry, painting and finishing. So again, you still got a full 30-day cure. It's not as durable as traditional oil, but it's much, much more durable than a latex. Even more durable than an acrylic. But you get all of that. It's still a little bit slower on the dry time, but it's not going to chip, and you don't need a bonding primer. Which I love about these hybrids is that we talked before about latex paint going over oil paint and how it just peels right off. In this case, with the oil, with this is called a hybrid or a waterborne alkyd, when you're applying it over an oil-based paint, you don't need a bonding primer. So you can use this material right onto oil-based baseboards. If you're painting over varnished trim, the oil bases and the oil resins that are in a material like this will coat and stick to the varnish. It won't flake off and chip off like a latex paint would. So there's some benefit to using this in certain settings where oil-based paint was used previously, and you don't necessarily need a primer. So before I say, in some situations you don't need a primer. Some materials they designed to work with each other. Some materials you don't need a primer at all for unless you're priming your spots for patches.
I think the color will determine if you are going to use primer or not.
The color?
Like if the surface is painted white, and oil-based paint was used, then you want to apply another color, then you have to use the primer.
You have to use a primer if it's not going to be white. Then I would recommend you using a primer. If you're changing materials, or if you're converting from oil to a latex, you're going to need a primer. If you are going to use a waterborne alkyd on top of an oil-based paint, they're compatible. They're compatible. Once the paint is dry, that the new coating is dry, it's basically an oil primer. It's basically an oil coat. It's an oil-based coating. But it's just like I said, it uses that water delivery system, which gives you the benefit of having an oil-based paint, but none of the disadvantages that you deal with in terms of making yourself sick to use it or having to use PPE to use it, right? So you can use this on, like I said, baseboards that have been painted with oil before. You can use this on varnished and stained trim instead of having to use a bonding primer for it. So there's a lot of benefits to using these products. It's really one of the best innovations in our industry. So we talked a little bit more about hybrids, and we'll go into urethanes. So urethanes, the cabinet right there, that's a urethane material. So urethane coating. Urethanes have to be put on a lot thinner. They require a lot more stringent preparation methods. The prep has to be done correctly. You have to make sure you're removing all dust, any dirt, all grease, because you don't want these coatings to fail. A lot of times the urethanes have to be catalyzed, or they have to be mixed 1 part and 2 part. Sometimes you have to let urethanes induce, which means after you mix them, you have to let them cook together and bind together in a chemical reaction. You have to let that chemical reaction happen over a certain amount of time before you apply the material. This in some cases, but these urethanes are extremely durable. They won't chip, they won't fail. This cabinet that I gave you right here, this cabinet, I painted that cabinet in 2019. That's been kicking around in my van and in my garage.
MDF material.
Yeah, it's MDF. MDF is notorious for chipping. It's notorious for swelling.
Yeah.
This material was painted on that cabinet in 2019, and I made a cut, the tic-tac-toe box. That's called a scratch test. So you put this tic-tac-toe box, you cut underneath the surface, and then you attach a really high adhesive grade tape to it, and you leave it on there, you press it on there, you warm it up a bit. And when you do that, you rip it off really quickly. And if any of the material comes off except where you made your cuts, that means you have a bad bind. So that's an actual scratch test. It's not just you take your fingernail or you take a piece of blade and you scratch it. You create a profile. You make a tic-tac-toe type of cut into the material. You put the tape on it. You apply heat and pressure for a little while, and then you rip it off really fast. And if any of the paint chips off from any area other than where you made your cuts, that's how you know you have a bad bind. So that's one of the ways that we test for urethane adhesion. Is one of the ways that we test for paint adhesion just in general. That's called a scratch test. Okay. So now you know how to do a scratch test. So if you want to know to make sure that your paint binds, you know how to do a scratch test now. Okay. The disadvantages to urethanes, they have to be mixed, like I said, and catalyzed. Sometimes you have to let an induction period happen before you can use them. The prep has to be done perfectly. You cannot skip steps. So before, when we say, oh, sometimes the people, they won't sand in between coats. You have to make a mechanical bond for this material. You have to create a mechanical key in for this material. You have to do a mechanical and sometimes a chemical key as well. You have to wash it with the chemical to clean all of the dirt and all of the contaminants, even after you paint it. Any dust that settles on the urethane, you have to remove all dust. Urethanes, in a lot of cases, should be applied in a shop, or they should be applied in very sterile conditions where there's not a lot of dust or dirt or wind or sun. It's very, very temperature and condition sensitive. So they have to be done correct. They have to be done, you have to be sometimes creative with the prep. You have to be creative with how you prevent things from happening and get into the issues. But the advantages are it's extremely chemical resistant. You can use it on just about everything. Most pipes, most industrial settings, urethanes are used. Most medical settings, they use urethanes. In schools and gyms and auditoriums, they use urethanes on the walls. In a lot of municipal buildings and commercial buildings, they use urethane top coats on the walls and on cinder blocks in different settings. Because of the chemical resistance, a lot of stadiums and basketball arenas and auditoriums with cinder blocks and community centers with cinder blocks, they all use urethane top coats a lot of times because, like I said, it's a lot less chemical resistant, it's a lot less scratching and marring resistant, so it's very, very durable. So it's perfect for those high traffic areas. It won't chip or peel. And again, you can use it on just about any surface that you can think of. So this is MDF, you can use a urethane. That's a polyurethane. You can use a urethane coating on metal. You can use it on glass. You can use it on this Stix primer that we demoed yesterday. That's a urethane coating. That's how it's able to bind to glass, into PVC, into all these types of surfaces. So these are some of the advantages of urethanes. You can get a urethane water-based coating as well as a solvent coating. So epoxies. Now, this is the professional grade for all coatings. If you can install epoxy and have it work correctly, that's the mark of a true craftsperson. The floor, epoxy flooring. Epoxies are also used in medical facilities because of their chemical resistance and their marring resistance. You can get an epoxy that's waterborne and you can use it on the floor. You can also get waterborne epoxies that can be rolled and brushed onto drywall and into masonry. So waterborne epoxies and solvent-borne epoxies, well, you don't really see much solvent epoxies, but what they are 100% solids. So it's just a lot of polymers and a lot of resins, and they pack it in, and then they put a very minuscule amount of a solvent in there, and the solvent is just to make it able to move and make it viscous. But if you ever used epoxy, it's like carrying, it's way heavier than normal paints. Epoxies and lacquers are some of the heavier paints because they add so much chemicals and they add so much, there's so much additives in it. It's extremely heavy. So epoxies can be used again on floors, you can use epoxy on tabletops, you can use it, they make tables with epoxy. You can pour it into a surface and you can get epoxy to pour up to 1.5 inches thick per pour. So if you ever seen those guys, they make those tables and they got those cool designs and look like an ocean floor inside the table. That's a poured epoxy table. You can pour epoxy onto a floor up to 18 millimeters per pour. So epoxy can go on extremely thick, it dries extremely hard, it has extreme chemical and marring resistance. It's one of the hardest surfaces that's created in the lab on Earth. That's why they use it so often on floors and gymnasiums, they use it on tabletops, they use it on anywhere that you can put an epoxy that would be beneficial, they use it there. Again, you can use epoxies on walls in the form of waterborne top coats or waterborne paints that can be rolled and brushed. You have amine epoxies that you can mix together and you can let it induce and then you can roll it on the floor. And the amine epoxies don't produce as much VOC, so they're not as toxic, but they're still just as strong and durable, and they last just as long as a 100%. Well, they're not as durable, I won't lie, but they do a great job. They outperform most other coatings. 100% solid epoxies are what you see when you see the guys, they pour it on the floor, they take the squeegee and they squeegee and then they roll it all the way out. That's a 100% solid epoxy. You ever other epoxies on the floor, you just roll it on. You don't need to have a squeegee and all of that stuff. So there's different ways to do it. They have different characteristics and there are different products you use. So some of the disadvantages to using epoxies, a lot of people don't like them because you need professional tools to do it correctly. You need to have the prep done absolutely correctly. These last couple of ones you cannot skip on the prep. You have to be very, very astringent and very, very astute in how well you do your preparation. For instance, we did epoxy floors, and when we do epoxy floors, we grind the floors down. I vacuum the floors 6 times, and we wipe the floors down with lacquer thinner. So we do a lacquer thinner mop. I use lacquer thinner because it soaks in and it emulsifies, it pulls dirt and grime out. So anything that may have been embedded into the floor from us grinding it, the epoxy, the lacquer thinner will pull it up, and then we can wipe it down, and it dries like that. So acetone and lacquer thinner dry extremely fast, but acetone is not as toxic. The difference is acetone is also not as astringent, so it won't do as well at cleaning and getting rid of dust and pulling up dust and dirt. So that's the reason we prefer to use lacquer thinner in part of our epoxy prep. Some people don't. I don't see how they do it that way. I do it the way I do it. That's the way I was trained. That's the way I learned to do it, and I haven't had failures yet. So that's the reason why I prefer that method. But you can do it in any setting. But in any case, the epoxy had to be done in certain temperature settings. So if it's way too humid, the humidity will sit. You know, humidity is water in the air. It's moisture in the air. So humidity will sit on top of epoxy and it will prevent it from drying correctly. It will affect the curing
That's
time.
when you see some bubbles on.
You'll see bubbles, right? So you have to take a blowtorch and you have to blow it out, or you have to use a spiked roller and roll it out to eliminate some of that. And even that, the only way really to do it is the blowtorch, because you're heating up the water and you're melting the water in the atmosphere. You're melting the water on the surface. But epoxy will sit on the surface. It will find the lowest, it's like self-leveling. It will find the lowest level that it can find and it will settle there, and then it will gloss over and close up a space. So it seals and creates a whole entire field. But in order to create this, you have to do all of the prep and go through all of the methods, and then you get the finish that you desire. Yes.
So why can't you just use concrete, self-level it and let it dry and then pour the epoxy?
You can. A lot of people do.
Yeah, because I mean, you save money and all that.
Not really. Self-leveling, I mean, even with self-leveling concrete, you still should use a primer, because you're introducing.
Yeah,
So you add.
still roll the primer, yeah.
There are epoxy primers that you pour out. So some of the primers for epoxy, you can use a polyamide primer, or you can use a 100% solids primer. Well, that's what polyamide is, but you can also use a vapor barrier primer. We talked about that briefly yesterday. So vapor barrier primers, what they do is you pour them on and you flatten them out, and they seal concrete from the bottom. So they don't let moisture come up from the groundwater. So they seal everything from the bottom and they create a shell. So it shields everything from below the concrete level. So sometimes you have situations in basements in certain areas near water, or where you're near a water shelf, where you can have moisture rise up out of the ground. The groundwater can come up and affect certain things, or can come up and cause issues. That's how you get a lot of cracking movement and all of that. But all of that is directed by the groundwater and how level the soil is and how dry the soil is and the sediment is underneath the house. And that will produce some of the cracking if water is moving or if the soil is wet. That's why houses have to settle for a few years after they build, right? Because you have to let all of the water and all of the sediment dry out, and then the house settles, and we're not worried about anything moving after that. But in those cases, we use a vapor barrier primer, and what that does is it creates a barrier so it doesn't allow moisture to come up through the concrete from the groundwater.
Is it 100%?
That's 100% solids, and it works very, very well. So we've used it a few different times and had great results. It's expensive, but you get what you pay for it.
One last thing with the epoxy. I'm interested in doing epoxy. I did it because when doing floor insulation, they give you it, but it's a very short, they just call it touch on.
Mm-hmm.
And they took us to a place in Mississauga. Now, that was that, but I'm really interested in it. I do remember a couple of the steps, right? So I thought I'll go to Jersey. Actually, I was tracing the one in Florida, but that one passed. It'll come up again. But I have family going to New Jersey, so I thought, okay, I'll just spend a week over there and do the program. But have you come into contact with a good epoxy company in Canada that they can do epoxy real good?
I do epoxy real good.
Huh?
I do epoxy real good.
You?
Yeah.
Yeah, really.
Yeah, really.
Yeah?
Yeah. I've been doing, the first time I did epoxy for was 2014. I did a pool.
Oh, yeah.
Yeah. I'm not teaching the class for nothing.
No, well, you do painting, yeah, but I didn't know you do like epoxy.
So painting and finishing. So I'm more of a finisher. A painter is like somebody who, they have the brush and roller, that's their main tools. I do painting, I do plaster work, I do staining, I do epoxy, I refinish kitchen cabinetry, which means I spray 2 different styles, both airless and HVLP. We do faux finishes, we do fine finishes, we stain staircases and railings, and we also stain decks and fences. We do siding. So I've been doing it long enough to say that I've mastered the things that I do very well, and I'm able to talk about it, right? So I'm telling you, yeah, we do epoxy. I'm not just saying it. It's like we do it, you know. So I'm talking to you about this one. So our epoxy company that does it, they have companies that train people how to do certain things, and the classes are great. The issue that I've come across with a lot of the classes is you're going to pay $2,000 for the class, and you're all going to compete for the same 30 jobs in a given area. most of the epoxy floors that you'll see in the classes, the way they teach them, and the fact that they teach them that way is to sell you the service. But you're learning the service, but you have to take what you learn and then go sell it somewhere. And for the price points and the work and the labor that you have to do for some of this material, the price points that they're charging for the classes, you need to book a lot of jobs. And I don't know if the price points always work. You can pay, one class will pay for the whole, one job will pay for the class itself. But you have to do multiple projects with this skill set. Most people don't want 12 colors and 1,000 designs. You'll see showroom floors maybe once every now and then, but that's not really the thing. Most of the time, the regular epoxy jobs you're going to be doing is garage floors. You're going to do a lot of chip flake. You're going to do a lot of garage floors with skid resistant and skid resistant coatings. You're going to see a lot of epoxy floors that are one coat, base coat, because people don't need all of the exotic colors and all of that. That's a nice thing to teach, but just to know the basic system of epoxy is very simple. You're going to learn that here. You're learning how these things work. That's half the battle, is knowing what to use where. So learning these things now, you already have a base level, because you know the difference between an amine epoxy and a 100% a polyamine epoxy and a 100% solids epoxy. There are differences between them. You know the difference now between a vapor barrier primer and a regular epoxy primer. There are differences in them. So you already know more than some of the people who do epoxy and pay for those classes. They don't teach that until the third day. You learned it day 4 here. And it's free for you. So you're welcome.
Thank you.
So in that way, as I said, there are some epoxies that are user friendly. You can go and get a kit from Home Depot. It won't be the same kind of stuff that you would use that you pour on and squeeze you on and roll out. But it's user friendly, it's durable enough, and people will go and use it. And you can learn that on YouTube how to do that. That's not a big deal, right?
I think Apex. I think it was Apex.
Yeah, they have different companies. There's some in Canada. A friend of mine's took one before. So we'll talk a little bit about paint sheens, and then we'll go into our practical part. So kids, we have different sheens for paint, of course. You have your flat or matte, and they produce very little sheen at a 0 degree angle or a 20 degree angle on the wall. So sheen is all about the angle that you look at the wall from. You're never going to see the sheen of a wall staring directly at it. What you have to do is go by degrees. So if this is 0 degrees, this table, then you're looking directly down at it at 0 degree. When you come here, it's a 45 degree, it's a 90 degree, or 90 degree here, and then a 20 degree here. So when we're looking at the degree of a sheen, we're looking at the reflection point from the degree or the angle that we're looking at it from, okay? So eggshell produces a sheen at a certain degree. Satin produces a sheen to a certain degree. Then you have semi-gloss and high gloss, and these all produce different sheens. You won't see much high gloss in latex because the paint is so rubbery and you have to apply it heavily, so you lose some of the sheen factor. So you'll see high gloss more with oil paints and urethanes and epoxies. You'll see a lot of semi-gloss with everything else. You can get a semi-gloss in a latex or an acrylic and it looks great. But a high gloss, usually they reserve that for solvent-based finishes, because solvents will lay down a lot flatter and they'll look a lot glassier and glossier. So they're more designed to have the performance that a high gloss coating would need. Matte paints you'll see is primarily oil and latex, or oil and acrylic and latex. So you can have a matte paint for anything. We're going to use our demo, and the paint that we're going to use for our demo is going to be a latex matte. So that's the paint that we're going to use. But then, again, you have all your sheens and you have all your different things that are used in different ways. And it's just important to understand the gloss levels and how things work correctly. So gloss level for semi-gloss, you want to use semi-gloss on trim and doors. You don't really want to use semi-gloss on walls unless the walls are pristine and perfect. Otherwise, any imperfection will show up. And the imperfections show up because the gloss factor, again, the paint shines at such a high degree and from different angles from a higher degree. So what that means is, if this is 0, I can tell semi-gloss from a 60 degrees down all the way down to 0. So when we scale back and we come here and we're looking at a wall directly on, you can't really tell it's semi-gloss. But when you turn your head and you see the light bouncing off of it from this angle, that's how you know. When you turn your head one direction and it almost looks like a piece of glass, that's a more confirmation that you're dealing with a semi-gloss finish. So understanding how the sheens work and how they work on angles is important. So you really won't see semi-gloss much on walls unless you're in a kitchen or a bathroom because they need the water resistance. Okay? You can get a semi-gloss paint and you'll see it mostly on doors and trims. Some accent walls you'll see they use semi-gloss paints on. But that's usually where they primarily serve. That's where they primarily serve their best purpose is at. Is the gloss paint. Satin, you can use anything. At this stage now, in decorating in residential sides, we're seeing a lot more requests for satin on doors and door frames and baseboards and window frames, as opposed to semi-gloss, because people think semi-gloss is a bit too shiny now. So they want something that shimmers and not that so shiny. So satin has more of a shimmering or a glowing effect. So it works very well on just the same kind of cabinetry and millwork as a semi-gloss. So that material there is a 20 sheen, so that's like a satin. So if we went a little bit higher in degree, it would be a semi-gloss. It would be a lot shinier. But even still, that's pretty shiny. So then you have your eggshell. This is reserved primarily for a lot of walls. Occasionally people will put eggshell on doors and frames, but it's primarily reserved for walls because it has a limited sheen factor. So the walls are shiny, but not too shiny. They're not too flat. So they have some sheen, and with sheen comes some durability. So the eggshell paints are a lot easier to wash and clean. They're a lot easier to scrub afterwards and remove dirt and stains from, as opposed to repainting over them. And then, of course, your matte and your flat. Now, matte and flat paint is what you see traditionally on ceilings. And they put flat paint on ceilings really because a lot of people who do ceiling work and who build houses and who tape and finish ceilings with mud, the ceilings can be done poorly. So if you were to put a semi-gloss or satin paint on a poorly finished ceiling, you're going to see all of the tape joints, you're going to see all of the mud problems, you're going to see all of the areas they didn't sand correctly. So it'll be a lot more unsightly because it'll show more of the imperfection because the sheen level is so high. So to prevent that from becoming a major issue, people use flat paint. Flat paint is used on ceilings because it has a lower sheen factor. There are some flat paints with zero sheen. So you stare at it at any angle and you don't see any light reflection coming off of it. You don't see any shimmer coming off of the paint. Light is not reflecting or bouncing off the paint surface at any given time. So that's a dead flat. Most ceiling paints are flat or dead flat. So that's an important thing to understand because then they have paints that you can use on walls that are flat. They have new technology in paint now where the paints that are flat now are washable and scrubbable. That's usually something that was reserved primarily for semi-gloss or gloss paints or eggshell even. So having paint now that's flat, that doesn't shine a lot, so that means it won't show all of the imperfections on the wall, and it's washable and scrubbable, means you get more durability for less headache in terms of doing all of the necessary prep to make a wall perfect. But you can paint it and it looks perfect because it's an optical illusion. The paint is providing you with no sheen factor. So that means everything blends in and looks consistent. You can make a whole bunch of mistakes, or you can do a whole bunch of dents and damage to a flat paint wall and then paint over it and without doing any work and stand back and look at it and it looks perfect. Until you walk up on it and start inspecting and seeing all of the issues. So understanding how those things work is going to affect your finishes. That's why a lot of times when you're walking, you have to use a light to do an inspection for your touch-ups and your repairs on flat walls, because just to stand and look at it, you can't really see it. So you have to keep that in mind as you go through. So all of these paints use different finishes. We walk through what kind of paint you can use on different surfaces. We walk through what paints are made of. We walk through the different types of paint and where you would use them at. So would you say you got enough out of understanding how paints work from this point? You need any more questions about how paint works?
This painting thing is like broad somehow. One cannot just understand everything until you start practicing.
Yeah, for sure. You don't. It's good to know these things before you do the practical work, though. But none of this works without having some practical understanding or practical experience, right? Because to understand how the material works, then it ties all of the theory and all of the educational parts. It ties all of those components together, like a solvent, like a binder. Huh? We combine the book learning, we combine the practical knowledge through the experience, right? Okay, so I think that's pretty much it for the book learning part. Any questions at all so far about paints, how they work, what they're made of, and where they should go on?
So, for the case of oil paint, if in case I'm painting goes maybe on the door frame, does it take too much time to wipe it off?
On the door frame?
Yeah, like you're painting the wall and you put on it.
Painted on the wall or the door frame? Does it take what you mean?
No, like, does it take too much time to wipe off oil paint in case you make a mistake?
To remove it?
Yeah, to remove.
It takes about as much time as you. It doesn't. So oil paint will sand to powder, like we talked about before. And when it sands to powder, that means it have a tight bond, right? That means it's seeped in. So to remove it, to sand down oil paint is a bit difficult because you have to cut underneath it, the surface, right? So you have to do a good job of removing it. So it can be difficult to remove oil paint. That's why a lot of times people don't remove it. Instead, what they do is they just use a bonding primer and they go over it, right? So understanding why that's the case is important to save you some time. You don't try to remove all the oil paint. It's almost difficult to do. You can use a stripper, and there are strippers that are available that you can use to remove these things safely without producing the dust and the dirt that comes from sanding. So you can use a stripper and it might remove most, but it's going to be difficult to remove all. You use a stripper and you do a mechanical sand, so use a chemical stripper and a mechanical and a sanding, and you'll be able to get most of it off.
Well, I think the best thing is for you to do the covering program.
Yeah.
Like you do the covering.
Mm-hmm.
You cover the surface so that like the paint doesn't touch.
Mm-hmm. What they say, the 5 P's, no? Proper preparation prevents poor performance, right? So you always want to do the prep correctly. That's the best way for you to prevent any kind of issues that might arise, right? Any other questions? Huh? We good. You guys ready to do some painting? Miss Desiree tired of learning, man. She ready to do some work.
Yeah.
Okay, so we know paint sticks. That's the extended version of what we have to do today. This is the one we normally use on walls, 4 to 8, or 2 to 4, or 3 to 5. This is a normal paint stick. You can reach most areas with this paint stick, huh? This one, go a little bit further. This goes from 4 feet to 12 feet. We can reach out and touch you. Go right to the ceiling from right here. No problem. Hey, how are you, buddy? You see? Very easy. We won't need this one inside here. We'll probably be able to get away with using this one, but it's good to have 2. Okay? So we'll go over a little bit briefly about brushes and rollers. So for exterior or interior painting, Purdy makes excellent things. Our friends at Sherwin-Williams donated some issues for us. So everybody's going to get a nice Purdy roller cage. And we want to use it with our nice Sherwin-Williams rollers. And this is what we're going to use for our demo today. Okay? So we'll have more of those. I also have some nice tools. So these are mini roller cages. Right? We used these yesterday.
Yeah.
So it's going to be one for each of you. You can come up and get them.
Where do we put all these tools? Why don't they give you a bag or a bucket for us to walk with them too?
Well, they gave it to us for free. They're not going to give us everything for free. You got to go buy some things. You know?
So what does a painter walk with? Like a bucket or it has paint?
You can get a bag. You can get. They have different things. You can get. Most people carry like a container that have all of the things. I drive a van and I push all of my stuff into my sites on a cart.
Yeah, because I was saying to the guys that yesterday, usually, carpenters, we pull a toilet and we have
cart.
one. So I'm wondering if it's the same thing with the painters or they like to take the bucket?
Some people do. Either way, but you're welcome to come up.
Yeah.
So just to get you guys started, so you have a mini roller. We won't need to use these today, we'll do the demo with one thing, okay? Now, the brushes that we have, they donated for us today, these are Purdy soft bristle brushes. Very nice. I like to use these brushes on walls. They're a little stiffer than most other brushes. I prefer to use a stiffer brush on walls because wall paint tends to be a little thicker, a little bit more viscous, and you need a better control of it. So a brush that's have a little bit more stiffness in the bristle, I think we go further. For baseboard and trim, like a brush with a little bit more flex in the bristle. The reason being is going to contour. So you take your hands and you wrap the brush around this, and you see how it contours, and it drags, everything levels itself out. These brushes won't do the same thing if it's too stiff, right? So feel the difference in the bristles between the two, and get a better idea on why. So everybody's going to get one of each. So you're going to get one brush for walls and one brush for trim. Are you giving him your brush? Oh, you don't want one?
I
No,
thought
don't worry,
that one
don't
was
worry. I'm just
for
joking.
fueling.
No, that's okay. These are your brushes now. So you keep so those are your two brushes. So everybody got a brush and a roller. We'll have other stuff next week too.
So I have 2 brushes and roller.
Two brushes and a roller.
Okay.
All right, and then I'll bring these up when we're time to get ready to start. All right, so I'm gonna take a little quick 5-10 minute break. I'm gonna get everything loaded up. And we'll walk through how to maintain the brushes, how to maintain the rollers. You all know how to clean your brushes and your rollers, right? You already have a tutorial on how to do that, right?
I soak mine in water.
Yeah, that's one of the best ways to do it. Okay, so we'll take 10 minutes and we'll come back and get ready to go inside the room.
Okay.